Okay, so this is how I designed and built my vector plane, which is based on the flight test FT Goblin. It's made out of 3mm polypropylene Correx board. So what I started off with was the FT wing, so the standard wing, which I built out of 3mm Correx. So kind of this stuff. Traced it out and then modified it heavily and printed it and traced it out and cut it out of the board. Then I wanted to design my own fuselage, this is the first iteration of it. After a few crashes and bangs up, I've finally cut this out because I heavily redesigned this, but very strong. This took quite a few impacts before it finally broke. This all damage around here is the actual damage from crashes, but the rest of it, the cutout, is not damage from crashes. It's me taking it apart to take the wing out and reuse it. So what did I start with? I started with the main fuselage, and that was my first sort of iteration, which is free drawn. You can see the nose is not very accurate, but it did okay. It did kind of go together okay. And then I went to this one, which I plotted in Design Spark Mechanical, which is a CAD software program. It's a free version from RS Components. And I went to this one. Then I reduced the size of it because I experimented with the CG, and I went to this size. So this is ideal size now. This is what the fuselage you've just seen was made up to the size. And the difference on this one, which I'm putting together, will be the angle of incidence. So the angle of incidence on the first one was just flat, there wasn't any, but on this one, with the motor mount at the back of the vertical and 90 degrees to that line coming off that, you can see there's a couple of degrees, I can't remember, it's 2 degrees or a little bit more of incidence, so around that. So that was just purely to trim down the elevons, but that was a bit of an experimentation. So this is what I've got to now. So this is a cardboard template, but the easiest method to do it is to print it out onto A4 sheets from the plans that I've made, cut round them with a sharp knife, so give it a good 10 or 20 mil all the way around. Obviously stick that together, so that's one piece. And the reason you give it that big area is that once you mount it onto your Correx board, you can cut actually the template out. So you can use this stuff, which is a stick and spray. There's different makes, manufacturers. You get it from a craft shop, and you would spray that onto the back of your paper template. You get some Correx board like this. This is an offcut I've got. After spraying it, you would stick that down to the board. Now, the main thing you have to get right is that this is at 90 degrees, so it's exactly correct, and this lines up, this line here lines up with one of the flutes, and you want to get it so the flute from here to here is parallel, is correct, is horizontal, and that there is a hole lined up for one of the flutes which is just below this line, so just, sorry, here, this back line here. Maybe I'll explain it very well, but basically what you're going to do is, if one of those holes, one of the three of the holes lines up, you can insert this rod, which will go from front to back, which is a carbon fibre, I think it's a 3mm rod or a little bit less, and that'll squeeze down, and you can glue that in place and then cut it off here with a Dremel or a saw or something like that, and that gives it massive amount of rigidity and impact resistance. And if you do smash it, like I've smashed this one quite a few times for different experiments, you just hot glue. It's a bit of a mess now, but it stays together, stops the nose completely ripping off. You can hot glue it, it's not pretty, but it just keeps flying. Unlike a foam board plane, which would just disintegrate to nothing and damage the wing, this will actually save the wing, and you can just keep reusing the wing. So that's the point of that, and it doesn't add a lot of weight. So that's the critical bit. You've got to get that kind of angle correct when you glue it on, and then you really have to take your time. So very close, and just cut down the line as slowly as possible. Now what's different about cutting Correx board compared to foam board is the fact that you've got like a knife section in there, so this gives it the strength, rigidity. Now when you cut along this way, so down, just above or below it, it cuts very easily through both of them. When you intersect with the knife to this bit here, the strengthening bar, if you like, the I-beam part of it, then the knife can wander. Unlike a foam board, there's a lot more control on it, so you have to be very precise. So one way of doing it is that you brace it, so you brace it say on a worktop or a table with some aluminium bars, and you would put your board or whatever you're cutting right up to that, or a piece of wood or something like that, so that stays in one place, that won't move as you cut it, because trying to cut it and say hold a ruler over the top of the template like that, or cut it freehand, what happens is as you cut and then get to the resistance of the eye bit, the knife wanders all over the place, and instead of being nice and straight, it'll be messy. But that's just experience. You just got to practice and find your best way of cutting it. Keep your fingers out of the way, obviously. And top tip is use whatever blade you use brand new blade, so you cut them a few times with say a standard knife blade and throw the blade away, because as soon as it starts to dull, you'll get very poor cut joints. And you can achieve really good accuracy and lightweight parts. So this is, for instance, this is now the cutout section from this template. Let's get that out of the way. So this is the fuselage I've created. So from all the parts, so it go together like a jigsaw. I mean, it'd be brilliant if you could CNC just cut these out and laser cut them out. And they weigh very, very little. I've got photographs and weights of all the individual components. And this would be the bottom plate, same again. It becomes a bit more tricky when you have to cut one section out. But I can show that in a later video. I've made a little tool that you can do that with. It's like and you can use a hook, or you can use a hook knife. But you try and keep this as neat as possible. You can actually sand this, it fares a bit, but you can sort of sand it down to very precise sizes. And then it would just fit together, and that's the base would fit together onto there, and that would wrap up to the front, and then you can glue that on like that with some sort of block, or to make sure, or a square to make sure that's 90 degrees, and they're all the sides are parallel, and you just kind of build it from there. And then you've got other sections which I've made, like the kind of like the front of the firewall, in front of the not firewall, but in front of the wing there. And you've got nose sections that would go onto here, and you've got strengthening points which I've included here, so they would glow on, that would go onto there, the camera mount goes on there, and then you've got the nose cone, and the nose cone is quite clever, the way that's being cut, it's just through experimentation. You cut it out of one piece, again using a template, you poke your knife through, maybe a smaller craft knife through, and then eventually just make that hole to provide the nose cone. So the same as, this one hasn't got a nose cone, but kind of similar to that one, the way this is. This is obviously the first iteration of what I made. Same with the rest of the components, so Vtx Mount, designed for a Matex, the top is quite self-explanatory. Underneath you'd have to quite slightly modify it a little bit, cut out so the Vtx would fit directly onto there. Engine mount out of 3mm plywood, something like that, put the holes in for the mounts. And then you've got all the back pieces as well, the strengthening parts on the actual back where the engine mount would be, so top, bottom, and also kind of the sides as well to strengthen it all, and then that would be covered on top. Nose cone, and then a battery cover across the, which is not here, across the top. So yeah, and what glue? Super glue. I did put some down, some non-stick like baking paper, if I spilled any, or some newspaper, and just literally just glued it together. Now with this you need to clean it. There's different methods on YouTube, you can flash it and all that with a heat gun, but you don't need to do that, you just wipe it with IPA, so that takes any oil or residue off this and prepares it so it's got a good base, make sure it's dry to put the super glue on, and just take your time doing it, just do a little bit at a time, but just make sure that it's 90 degrees, because once you commit it kind of sets quickly. You can correct small mistakes and take it off by using acetone or a branded solvent, that will remove the super glue, but I think it may eventually start weakening the plastic, but you can tidy it up if you've made a bit of a mess, and it doesn't really matter. Once it's glued together, it's amazingly strong. I mean, I had to take a Stanley knife to get this apart, and as I say, I smashed this full into the ground, and I just glued it again. That's it, straight off flying, replaced the batch cover, and it was away. But this has had many flights on it now. It's probably had about 60 or more test flights from scratch. Crashed many times until I got everything correct and I knew where the CG needed to be and the actual design. And hopefully this one, I'm hoping not so many crashes, because from what I've learned from this first one, we'll go into this one. This is why this one is going to be a lot more neater and it's going to look good. I'll spend quite a bit of time on it. So yeah, and that's it.